In this video, we're going to develop the unit circle. When I mean a unit here, we're talking about a radius of 1. So when we embed our right triangle within a circle on the Cartesian plane, that hypotenuse will always be a 1 no matter where I put the point x comma y. We've also discussed how do we find the sine, the cosine of the tangent in a Cartesian plane. We've learned that sine right now is defined as y over the r, but when we put our r as a 1 value, that ends up turning into y over 1. In other words, sine is going to be equal to y. Cosine, we've learned that as x over r, but again, we've stuck that r at a 1 value, so that makes it x over 1, which means cosine is now going to be equal to x. With the next trig function is tangent, which is y over x. Notice that does not incorporate the r value, so it will stay y over x. And then we have all of our reciprocal functions. So since our sine is now equal to y, the cosecant would be 1 over y. Now that cosine is equal to x, secant is going to be equal to 1 over x. And tangent, since it is y over x, it still stays x over y. Now, a really important point to notice here is that we have ordered pairs that we write as x comma y's, but now that our cosine is equal to x and our sine is equal to y, we can think of our ordered pairs as cosine comma sine. So if you look at a net ordered pair now in a unit circle, the x value will tell you what the cosine value is, the y value is going to tell you what the sine value is. Okay, and next thing we have is what we call the 16-point unit circle. Now what this is made up of is all of those angle measures from the special right triangles that you've learned in geometry class and that we reviewed here in trigonometry. We have the 30, 60, 90 triangles, we have the 45, 45, 90 triangles, and we also have all those quadrant angles like 90 degrees, 180 degrees, 270, 0, and 360. Put all those angle measures into one circle, and you have a circle that looks something like this, okay, where we have our angle measures in degrees. We can convert those into radians, and then we can work our way all the way around the unit circle. All those dashed lines there, I want you to think of those as a hypotenuse for a right triangle. So if I start at 30 degrees and I were to draw a line straight down to the x-axis, there you see a right triangle here, which would represent a 30, 60, 90 triangle. And we had rules for it. Now, we're going to go ahead and assume that the radius again is a 1 since we're in a unit circle. The radius is always twice the length of that shortest side, so 1, if you divide that in half, that makes this a half. And then the longest leg of our triangle is that 1/2 times the square root of 3. So you could think of that as root 3 over 2. So if I were to ask you, what's the cosine of our angle starting here, that's that 30 degrees. Cosine we know is adjacent over hypotenuse. Well, our adjacent side is root 3 over 2. The hypotenuse is 1. So the cosine is just going to be root 3 over 2. The sine, that is the opposite over hypotenuse, so 1/2 over 1, in other words 1/2. And what this does, it creates an ordered pair, and it tells us the location that an ordered pair is on the unit circle here. That's where the root 3 over 2 comma 1/2 comes from. And you could do this again by making a 45, 45, 90 triangle out of this. Well, again, our radius here is a 1. The length of that is a multiple of root 2. So we can think of this as square root of 2 over 2 if we go through the whole rationalization process. And that's an isosceles triangle, so they're equivalent. So the location of that ordered pair is going to be root 2 over 2 comma root 2 over 2. And you can continue this on throughout the entire unit circle. So the next ordered pair here would be 1/2 comma root 3 over 2. Jump up to 90 degrees. Now this one's a little different because we're up here on the top. We do remember that the length here is going to be a 1. We can't create a unit circle out of this, but we can call it an ordered pair. That would be at 0, comma 1. And the next thing I want to do out of this is, well, we've got sines and cosines. Remember that the x value of an ordered pair is just our cosine value, and our y value is the sine value. Can we find the tangent out of this? Well, let's go back to what we know about tangent. Tangent is supposed to be the y value over the x value. So let's take our y value from the ordered pair and our x value from the ordered pair, and let's divide them. That's 1/2 over root 3 over 2. Well, dividing by a fraction, that's the same thing as multiplying by the reciprocal. So the reciprocal of root 3 over 2 is 2 over root 3. Now the 2's are going to cancel out, leaving you with 1 over the square root of 3. Rationalizing that fraction will give you root 3 over 3. So the tangent at 60 degrees, not 60 degrees, but 30 degrees, or pi over 6, is going to be root 3 over 3. And just like I worked it out over here to the side, you can go through that for every single one of these ordered pairs and get a tangent value. Maybe you notice here that we would have y over x. That's something over itself. Oh, excuse me there. Go back to that. Y over x, that is something over itself, so that would give you a value of 1. Then root 3 over 2 divided by 1/2, that will give you a tangent value of root 3. And then finally, going up to the quadrant angle, 90 degrees, if we're going to take the y value divided by the x value, we're taking 1 divided by 0. Now, we are not allowed to divide by 0. We remember that as being undefined. So there are tangent values that are undefined. Going through this entire circle, you're going to come up with all of these ordered pairs that we have here. You see that we're in the second quadrant. All of our x values are going to be negative. And when we try to do our tangent values, we're doing y divided by x, a positive divided by negative, so all of our tangent values are going to be negative. When you go down to the fourth quadrant, not the fourth quadrant, but the third quadrant, we have negative comma negative. Everything's going to be negative. But when you try to do the tangent value, you're taking a negative divided by negative, which is a positive, so you see why all of our tangent values are positive. And then the last quadrant, the fourth one, we're in where all the x values should be positive. Erase that one there, that typo. All the x values should be positive and all the y values should be negative. Again, we're taking a negative divided by a positive for the tangents, so all the tangents in this quadrant are going to be negative. And keep in mind too that we have another quadrant angle down here at 270 that if we were to do its tangent, it's going to be also undefined. Okay, so we have all of these values here. Now we don't have to worry a lot about reference angles. We don't have to worry about trying to make right triangles. We can then just go in and use our unit triangle as a reference, more or less. So let's try an example of finding a trig function here. Okay, so let's do the sine of 135 degrees. Okay, here's our reference angles, or not our reference angles, but our unit circle. Let's find where 135 degrees is at. There we are, we're in the second quadrant. We know the sine is the y value of the ordered pair. So what is our y value here? Looks like we got square root of 2 over 2. So therefore, the sine of 135 degrees is going to be square root of 2 over 2. And that was pretty simple. We didn't have to do any conversions. How about the secant of 180 degrees? So if you remember that secant is the reciprocal of cosine, maybe we can figure out what the cosine value is at 180 degrees. Cosine is the x value of the ordered pair, which is -1. Secant is the reciprocal of that. So no matter what I would do here, if I were to reciprocate -1, I'm still going to have 1 over -1. Therefore, secant of 180 degrees is still equal to -1. A third example, -300 degrees, the cotangent of it. Well, that's going to say, what's the reciprocal of that? What's the tangent of -300 degrees? Here's how I find where -300 degrees is. I go to my unit circle and I start at the x-axis on the positive side, and I find where 300 degrees is. I see how far I go with lines. All I do then is I go backwards the same number of lines, and now I know where -300 degrees is, which is at 60 degrees, or pi over 3. What is that tangent value at that particular angle measure? Well, I wrote my tangents in pink. I got root 3. So I know, for now, the tangent at -300 degrees is root 3. The cotangent is the reciprocal of that. So I have to flip my fraction, rationalize it to give us root 3 over 3. So the true value for cotangent of negative 300 degrees is root 3 over 3. Got a couple more for us to look at. How about radian measures? What's the cosine at 3 pi over 4? Well, let's locate the radian measure, 3 pi over 4. Here is the radian measure. Cosine is the x value of the ordered pair, so I need to find the x. That happens to be negative root 2 over 2. So therefore, the cosine at my radian measure is negative square root of 2 over 2. One last example to look at. How about the secant of a negative radian? Well, let's look at the reciprocal of that, which happens to be cosine of negative pi over 4. Figuring out where negative pi over 4 is going to be at, let's go with where's positive pi over 4? 1, 2 lines. That's where positive pi over 4 is. So then that means negative pi over 4 is going to be 2 lines in this direction, and I end up at 7 pi over 4. What's the cosine of that angle? That's the x value. So that's root 2 over 2. So I know that the cosine of my angle right now is root 2 over 2. But secant is the reciprocal of cosine. So again, I have to flip my fraction, go through the whole rationalization process, and you'll see that the 2's cancel out, and I have square root of 2. So therefore, the secant at negative pi over 4 is the square root of 2. And that is how you can use the unit circle to find the exact values for any trig function at any angle measure or any radian measure.